Hello guys, I hope you are doing good. Welcome to another video. Today we are going to solve yet another interview question. This is a principal engineer interview question that was asked in Atlassian's interview. As you can see on this article which was posted, or the interview question which was posted on LeetCode. This is a fairly new interview question. It was shared on May 22, 2025 this year itself. So there were 3 rounds that were asked to the in candidate, and so build a tab component with some variations like lazy loading we have already solved. You can watch that video. I'll add the link to this in the description. Today we are going to solve the second question, which is build a function to measure performance of any given functions. So evaluating functions performance is very important as a principal or a staff engineer, because your ultimate focus when you are at a senior level is doing the optimization, making sure that the website or a web application or your application functions optimally in any given conditions. So one way is to evaluate like how the function is performing, because in JavaScript we support functional programming, so everything is converted to a function. So it's a necessary thing to evaluate the performance of the functions to make sure that they are working properly, they are optimal, and there is no bottlenecks. This also helps in finding or debugging the functions, like which one or which particular function is the leading cause that is slowing down the application. So we have to create this. Now if you see the example, we have to create this measure performance function. This measure performance function will take a synchronous function, or it can take a synchronous function as input, and then we have to provide the name to this function. If this name is not provided, we should pick a default name, which should be asynchronous function, sorry, anonymous function, in case if the name is missing. Then the iterations, number of time this function we have to run to evaluate its performance, and then either we have to do the warm up or not. So before starting the evaluation criteria, if warm up is true, we run the function once to make sure that the function is not throwing any errors, and then based on the number of iterations it do, we'll have to return the result, which is the type of function. So this is a synchronous function. The number of iterations we did was 5. What was the average time to run this function? It was 10 milliseconds. The minimum was 9, the maximum was 11, and if we do the average of this, we get 10 milliseconds. So that's what we have to find out. Similarly, we have asynchronous function, and this measure performance functions that we have to create, it should take the synchronous function and all the options, and then it should evaluate or test like how much time the function is taking to complete the evaluation. So we'll be creating this measure performance function. Let's see how you can create this. Let me copy this asynchronous function from here. This is a sample one, and also the synchronous function, which is the normal function. This is what we are going to use for the evaluation, and let's create the measure performance. So I'll keep those at the bottom, and then here I'll create the measure performance function. See, because the measure performance has to handle async and sync both functions, so the measure performance function itself will be an asynchronous function because it has to handle the asynchronous functions as well. So async function, and then measure performance, and then this will take a function as input and options. Now you can set the default values to the options here itself, or you can do it while destructuring. So let's do it on destructuring. So options, I've set the default value as an object, empty object, and here we'll take the name. So function has a special property name that gives us the name of the function. So let's say on the measure performance, if you use this as function.name, it will give you the measure performance. Otherwise, we can say anonymous function. So it will pick the name, and this will be an equal to operator. Then the iterations will do one iteration at max, and then warm up will set it true by default, and then log results. So this is just a flag which we can use, where this will tell us whether we have to log the result, which will console log it, or we have to return the result. So I mean, it's not a necessary one, but it is a good one to have. And then let's create the result object. So we'll have the result object, and in the result we'll return the name. As you can see here, we are returning the name. So the name of the function will return. We'll also return the number of iterations it went through, and then whether this function is asynchronous or not. So for that also we have a special property. So if the function dot constructor dot name equals to async function, which means this is the asynchronous function. So any asynchronous function that you create, and if you access its property of dot constructor dot name, it should return you the async function. So this is how you can check if a function is async or not. That is another question that you can expect in interviews for the junior roles, not for the senior roles. But yeah, this is how you can check whether a function is asynchronous or not. And then the timing. So for each iterations, how much duration it took to evaluate or to run the function, that will be storing it in the array. And then the average. So average will be 0. Then the minimum value by default will be infinity, the max value, and the maximum value will be minus infinity, which is the least value, and then the total. And now let's try to run the function. So let's say if the warm up flag is set, then what we are going to do is we are going to wrap the function in try catch, because this is a synchronous function. So we have to wrap that in try catch, irrespective whether your input function is asynchronous or synchronous. You can use the await keyword to run it. So if it is a synchronous function, it will run instantly. There is no waiting time. If it is a synchronous function, then it will wait till the function is completed, and then it will move forward. And otherwise, what we'll do is we'll do a console error. So console.warm warm up run failed for, let's use the template literals, and here we'll say the function, here we'll have the error. So this will do the warm up. After this, we'll run the function. So let's have a for loop for let I equals to 0, I is less than iterations, and then I plus plus. And within the loop, what we are going to do is we are going to do the same thing. We are going to run this function. So let me copy this try catch. And here, if the function throws error, we'll do continue. So we'll skip executing the code after this, and we'll terminate the loop, and we'll go to the next count in case it throws error. Otherwise, we have to check how much time this function took to complete. So for that, I'm going to use const start performance dot now. So this will be the starting point, and then once the function is completed, we'll do const end is equals to performance dot now. This will be the end time. So performance now returns the timestamp. So this will be the starting point. This is before the function started executing, and then this is the end point where the function has executed. We got two timestamps, and then how much time it took is the duration, and that is end minus start. And now let's store it. So results dot timings dot push duration. So in the results we are storing the durations. We have created the results object before the for loop here itself, so that we can use it to manage the state. And then we have results dot min. So the default value on the min, we have set it as infinity. So here what we are going to do is math dot min, because we have already set the max value, so we are going to use the results dot min, the existing max value, and then the duration. This will give us the minimum value between both. Similarly, let's get the max value. So here we'll have max min dot max, here max, and then the duration. And finally we'll have total. So results dot total time after each iteration. So this will be a summation of the duration. This will use to calculate the average time. Once this is done, outside the for loop, we are going to do or calculate the average. So results dot average equals to results dot total divided by results dot timings dot length. So either you use timings dot length or you can use the iterations also, but timings dot length is a more concrete way to evaluate the average time in case you encounter error. Because let's say if we encounter error at any evaluation, we continue, so we don't do this processing. So it's better that we use the result dot timing, so the number of items that we have and the duration, to get the genuine result. Otherwise what will happen is the totals, and then if you divide it by iterations, in case of error it will give a wrong result. So we got our results, and now finally let's do, if there are log result, if it is asked to log the results, then we'll log it, or what we have to do is we can return it, return the results. So you have done the processing, you can return the results. Because this is an asynchronous function, it will return a promise. So you can use the enable promise, or you can again use the async await to get the results and print it. Otherwise we can log the result here itself after the processing. So I'll just copy these things. So console.log, and here we'll have the performance result, and whatever the name is for the function, and then console.log iterations, and then min and max value and average. So we'll have average, that will be your results dot average, and then min and max. So min results dot min, and then max. This will give us, or this will log the output. Now let's test this. So we have our measure performance function ready. Let's copy this. We have our asynchronous function. Let's test or evaluate its performance first. So we'll use the measure performance. We'll pass this async function to it as a argument, and then after this what we are going to do is we are going to copy these three things, and we'll pass the options, and then we save this, and now let's run it. So let's reload and see what output we are getting. So average was 100 milliseconds, minimum was 100 and maximum was also 100. This is because this promise is resolving it after a delay of 100 milliseconds. Let's do 125 or 120 and see what will be the output. So see, we are getting the same output because this is the time that each function is taking to resolve, which is 120 milliseconds. So that's what we are getting as an output. Now let's comment this and let's go to the sum function or sync function. So here I'll just copy the sync function, and this was async calculation, my bad, and this will be a synchronous calculation. And let's see the output. So the minimum time it took to iterate over 1 million array counts was 0.69, maximum it took was 0.79, and average it took was 0.71. If I close and reload this, and let's see, so again minimum it took 0.69, maximum 1.2, average 0.83. So it keeps on changing depending upon how fast this happens. Now let's do one thing to test like if the sync function is working properly or not. So what I'm going to do is I'm going to add this variable count and set a default value and then have this count, and let's do a memoization of this sync function. So what it will do is memoization will run this function once, and after that it will cache its value, and if we are calling the same function again, then it will return the value from cache rather than running the same function. So let's create the memoize function. So const memo, this will take a function as input, and then it will return a function that will have to invoke, and here we'll have to cache the computed value so that we don't do the recomputation. So let's create a cache. This will be an object, and then here we are going to create a unique key, and the key should be unique in respective to the arguments that this function receive, so that when the function's argument changes we trigger a recomputation. That should be the ideal case. So json.stringify, and then arguments is a special keyword available within the function that returns us all the arguments of the function. You can also do rest operator and args and collect this and pass it over here, or you can use this arguments function. So let's do this for simplicity so that you understand the modern flows. And then here we'll say that if cache has the key or the cache has the value, then return it, return cache key. Otherwise we'll have to do the evaluation. So const evaluated value, and then we'll pass this to argument. So here we are spreading it, and then after this in the cache we store the evaluated value, and then finally we return the evaluated val. So now let's test, like if we memoize the function, is there any difference in the performance evaluation? So this is our normal function, and then below this we are going to create a memoized function. So let's create this const memoized, and here we are going to have the memo, and to this we are going to pass the synchronous function. And now let's pass the synchronous function over here and memoized to this function, and let me rename this as memoized, and then we'll see the result. Now if I reload, you'll see that in the normal evaluation for the synchronous results, the minimum time it took was 6.9, maximum it took was 79, 0.69 and 0.79, and average it took was 0.72. But for the memoized, the maximum it took was 79, which should be, I think, the first case where the evaluation happened, and after that it cached the value. So post that, for all the iterations we got the result in the minimum time of 0.1, so average is 0.6. So this is how we can measure the performance. If you notice, there is a drastic performance improvement in the memoized function. So this is how you can create a util function measure performance to evaluate the performance of the functions. The third question in the list was designing the Google editor. So for that, you can enroll into my course. I have around 17 front-end system design questions that you can learn. So everything that you need to prepare for your interviews is available over here. I'll see you in the next video with another interesting question. Thank you.